Hello, everyone. In this video, we're going to look at our final exploration of section 2.1 and 2.2 on the elementary derivative rules. So go ahead and meet me here in your notes for this exploration. So here we're told that we're given a graph of the function f of x equals sine of x. So just to take a moment to review for yourself how this function should look. So sine of x starts at 0, goes up to 1, back to 0, down to -1. And just recall some values here. So we go up to 1, down to -1. An entire cycle is 2 pi. We have just pi in the middle, and then we've broken up by half a pi's. It should look something like this. We don't need to decorate it with the numbers, but just to get a sense of what's going on here. Okay, cool. Now we're told on the same set of axes, sketch rough graphs of f prime and f double prime, the derivative and second derivative, labeling both of them. Then use your graphs to guess the formulas for the derivatives in the box on page 39, which is down here. So what we're doing here, we're going to use some colors to get us started. So the function that we're going to start with here is f, and that is the sine. So I'm going to go over this function f in a highlighter, yellow. So here is f, sine. So now let's see, compute what the derivative should look like. Well, here I can first notice some horizontal tangent lines. So my derivative is going to be 0 at those x values. Alrighty, so now what else do we see? Well, we see that our function is increasing here. So our tangent, or our derivative rather, is going to be positive. Here we're decreasing, so we're going to be negative, positive. Here we're increasing, so it'll be positive, decreasing, negative, and then increasing, so positive. So our function will probably look something like, start here positive, be negative, positive, negative, and then positive. Okay, so that's our derivative. So now let's consider the derivative of the derivative. Well, we can first find some horizontal tangent lines on our derivative. So our second derivative should be about 0 here, 0 there, 0 here, 0 here, and 0 here. And so let's notice what's happening to our derivative. Well, here we're decreasing, so our second derivative should be negative. All through here, we should be negative, so I'll draw that in. Negative here. Then our next chunk here, from here to here, our blue derivative is increasing, so we should be positive. Then negative and positive. There's kind of a lot going on this picture, but let's just take a step back to reflect on what it looks like is happening. So recall the yellow is our original function, sine. The blue is our derivative. And the red is our second derivative. So what do you notice about the shape of these graphs for the derivative and second derivative that we're getting? So you might recognize that our derivative is kind of looking like the sine function, or cosine function rather. So the cosine function is just the sine function, but it's shifted over to start at 1. So this derivative looks like cosine of x. The red function looks almost like a mirror image of our yellow function. So it looks like the reflection of the sine, which is how we write that mathematically, is negative sine of x. And it turns out this is the case. So the derivative of sine is cosine. So we can write that in this more derivative box. Derivative with respect to x of sine of x is cosine x. And if we look at what we just done, well, if f prime is cosine of x, and we've looked at the derivative of it, that looks like negative sine x. It turns out that is the case. So the derivative of cosine is negative sine of x. So for these trig derivatives, it might take a while to get used to this pattern and to get used to, okay, derivative of sine is cosine, derivative of cosine is negative sine. One way that's helpful to think about it is to imagine the sine function. Imagine what the tangent lines are at a point. Oh, they start positive. So the derivative is a positive cosine. And then consider the cosine function. So here's our cosine function. Starts at 1. What do the tangent lines do? Oh, they're negative. So the derivative of cosine is negative sine. So that's one way to help us remember. But again, the more problems you do, the more comfortable you'll be and the deeper understanding you'll have for these derivative formulas. Awesome. All right. Thank you for watching, everyone. You have some more examples and exercises to work through. Keep up the hard work.